Let us now discuss about push-down automata. Like, what does this PDA do? It overcomes the drawbacks of finite automata. What kind of drawbacks does this finite automata have? Finite automata has limited amount of memory, so it only recognizes the regular languages, but PDA recognizes context-free languages also. Basically, pushdown automata has 7 tuples, that are q, summation, tau, delta, q naught, z naught, and f. Only tau and z naught are new to us. Tau means stack alphabet, z naught means starting stack symbol. Okay, q means set of states, summation means input alphabet, means sigma means input alphabet, delta means transition function, q naught means initial state, and f means final state. So instantaneous description, what does it have? Transition function of state, top of the stack symbol, input symbol. Okay, we have two conditions for a string to be accepted in PDA, that is, stack should become empty and when string reaches the final state. Also, if we give a particular example like a parent, b parent, a does means stack has only two operations, right? One is push and another is pop. A means push and B means pop. We'll be popping element A, like character A. Let us now discuss the example. See, initially we'll push all A's into the stack. Whenever B occurs, change the state. If we are in the state Q0, change it to Q1. Only when the first B occurs, okay? Change the state and pop A from the stack. Repeat step 2 until the stack is empty. A parent and B parent, right? Let us take n is equals to 3. Then we'll get A, B, B, B. We'll always end the string with a null, epsilon. In a transition function, we have to write state, input and top of the stack. Initially, the state would be Q0, right? So what is our input right now? Input alphabet, it is A. So we'll be writing A. What is the top of the stack? Top of the stack initially is Z0, always. Okay, in any type of question, Z0 is always the top of the stack initially. So Z0. The output would be Q0, comma, top of the stack is A, Z0, right? We have pushed A, so the top two elements are A, Z0. Now we have transition function as Q0 is the state, input alphabet is A. The next input alphabet is A. What is the top of the stack now? We have A as the top of the stack. Before there is nothing in the stack, we only have Z0. So Z0 is the top of the stack. Now we have A, right? So Q0, A, A. Now the output will be Q0, comma. What are the top two elements? Input alphabet is A, right? So we pushed A. So now what is the top of the stack? Like top two elements. A, comma A. Before, top two elements were A and Z0. Now top two elements were A, comma A. Okay, next what will happen? We'll again have a transition function, the same Q0 state, and the input alphabet is A, right? And what is the top of the stack? It is A. Next it will be the same state. We'll only change the state when input alphabet B comes, so we won't change the state. Q0, comma, what are the two? Like we'll get another A, right? Because we pushed one A, we'll get three A's and Z0 now. What are the top two elements? A, comma A. A. This is same as this, so we won't write this again. We'll just do it. Now we are done with 3 A's. Now B. Q0, comma, input B, comma, what is the top of the stack? It is A. And Q1, comma, epsilon. We are changing the state because B occurred. Only the first occurrence of B will be changing the state. So Q1, comma, epsilon. Why epsilon? Because I already told you, right? A is for pushing and B is for popping. We are going to pop this element. So Q0, comma, Q1, comma, epsilon. We popped that. A. Next, Q1, comma, B is the next input alphabet, and we have A again. The top of the stack is A. What are we going to do? Q1, comma, epsilon, because we are going to pop this again. Write epsilon when we are popping anything, okay? Over here. Next, Q1, comma, epsilon comma z naught. Why? Like we will be having another state over here, that is q1 comma, we have another b, right? Input b comma, what is the top of the stack? A is equals to, we won't be having this, q1 comma, we'll be popping this also, so epsilon. But this and this are same, so we won't be writing this. Here another state will be there, we won't be writing it, and here also another A will be there, we won't be writing it. Here another B also, we won't be writing it. Now at the end, what is our last character? It is epsilon. So q1 comma, input is epsilon, top of the stack is z0. We only have z0 over here. What are we going to do? We are going to pop the z0. Here all B's are over, we came into, so we will be coming into a new state. A's are over, we came into a new state. B's are over, we will be coming into a new state. So epsilon, q2 comma epsilon. Okay. Okay. Now how do we draw this? See, we have q0 on A. q0 on A goes to q0. q0 on input A goes to q0. q0 on A goes to q0. But we are changing z0 to az0. So A comma z0 slash az0. Okay. Next, q0 on A is becoming q0. Sorry, q0 on A goes to q0. A is becoming AA. Right. q0 on A goes to q0. A is becoming AA. Basically it's simple. Just write q0 goes to q1, right? q0 goes to q1. Keep a transition. Keep b comma a slash epsilon. Next, q1 goes to q1. Keep a self state. b comma a slash epsilon. Next, q1 to q2. Epsilon comma z0 slash epsilon. It's just that, just write q0 to q0, draw a transition, like draw a line or loop, whatever it is, and then write a comma z0 slash az0, a comma a slash aa, b comma a slash epsilon, b comma a slash epsilon, e comma z0 slash epsilon. This is the transition diagram. Thank you.